There should be two.
Okay, we'll get started. A bit of a extra good night tonight because in principle this is our 50th anniversary this meeting. So 50 years ago, I'm not about to go into days or hours or whatever, 50 years ago we actually had our first meeting of the Frankston Society in the Mechanics Hall in Frankston. And I'll have to say we had a lot more people turn up to that than we had tonight. We got so many people turned up it frightened the hell out of us. We easily filled up the Mechanics Hall, and I guess there was a sort of a rush going on because of the space landing.
I don't know if I can transfer.
How many people tonight are absolutely sick and tired of the word oh?
I'm sick of talking about it.
Yes, yeah. I reckon we should start following 90. But at the time there was a lot of excitement in the community, and you really couldn't go anywhere without people talking. So the media was just like today. The media are going bonkers over the 50th anniversary. At that time, they were going bonkers over the fact that we might be landing on the moon, and there was a lot of argument about whether we should be going or whether we had a right to go.
Or actually going.
Or actually going, yeah. I remember some of the churches were doing a, if God had meant us to go to the moon, He would have put us on the moon. And there was all that sort of argument going on. But all you have to do is say, we're going to put a telescope in Frankston, because all our activities are in Frankston, and you just put one of the 4-inch, one of these 50mm refractors into where the cinema is now. That was actually open parkland at that time. And you don't have to queue of people. You didn't have to advertise it, you just put the telescope down, all the people turned up. In those days we weren't making money, so it wasn't something we were worried about. But, yeah, it was interesting. And so this Saturday we've got our society dinner, the 50th dinner. Did you want to say anything on that day? No, silence. So the society dinner's on, and the food and that are all organised.
Oh, you need to book on, is it?
Sorry?
They need to book on.
Is that still going, is it?
Yeah.
Yeah, okay.
So they can pay tonight though.
Yeah, you need to pay $5. The dinner is more than $5. You get your $5 back?
No. That's just a contribution towards. That's just subsidising.
You mean I paid my $5 thinking I was going to get it all back?
Have you signed the book?
One of the things I've discovered about retirement is that you start looking at the money very closely. Yeah, so that's on this Saturday. So if you go on the website, you can or go to try bookings. You can book for the dinner, and it is a $5 fee. What else have we got that's going on? We've got the Vastrock coming up in 2 weeks, 3 weeks?
Yeah, I need your abstract as well, and topic.
Oh, you
Everyone's
really
asking me.
You want to know what I'm talking about?
Not me, everyone else wants to know. I couldn't care less.
I'll give you a short.
No, just put it in an email.
In 1800, the people that established amateur astronomy as a defined activity were going to school at Cambridge University. And in 1833, those guys, well, 4 of those guys, were actually the leaders of all the schools in Cambridge University. One of them was the Master of Trinity College, and the others, including John Herschel, and off the top of my head, others, leaders in their field were not happy about the way that science was going. So they defined what they thought was the future of science. And the principal things that they were looking at was people that are doing science should be paid for doing the job. So they brought in the idea of tenured lecturers. They wanted the structures that were around for discussion and meetings, they wanted them to become more professional. So all of a sudden the Royal Society, which was up to here in people who knew nothing about science but liked to be associated with it, they got told to go forth, and so the people in the Royal Society suddenly became professionals. The moment they defined professionals, they had to define the opposite, which they defined as amateurs. These were people that were still doing science, maybe doing astronomy, but they were not being paid in the education system. And so they created amateur astronomy.
That's a bit long for an abstract. Just
Yeah.
one.
Yeah, no, I'm just explaining, so you understand.
I have
I'll write it to you
And I lost
in
everything after and.
20 words or less.
All right.
150 characters.
And the whole, I'd have to say from that point on, the whole amateur system fell apart. The professional education system took off and is in the process today of falling apart. So it was in that period, that 19th, 20th century, that science took off. Sorry? Oh, yes, you do. You need to know about the life of Herschel. You need to know about the life of Einstein and all those sort of people who were amateurs that had to become professionals because the university said so.
And then you got the hecklers.
And you got the hecklers, of course, which I'm not sure if they're amateur hecklers or professional hecklers.
Amateur, very amateur.
Peter Stilton's giving a talk to the Frankston, is it the Frankston Library or the Frankston Arts Centre? Anyway, I'm going to go down and heckle him while he's giving
on the
his
fruit
talk.
peanut.
I'll come and heckle you if you like. They never got to the moon.
No, my talk's not on the moon though.
We've also got the concert coming up the month after that, and that'll be in here, and it'll be a nice sunny day. I'm absolutely sure of it. If not, I'm not going to be here. And what else have we got coming up? Can't remember. My memory is really going lately. All right, the speaker for tonight. Yep.
Peter, can we have a DPI limit on the concert?
Oh, absolutely. What, 150?
No. 87.
You get, well, yeah, earplugs will be provided.
All right.
Earplugs are being provided there, Robert.
Good, thank you.
Also give them to the band as well.
Now, Trevor's going to give the, I guess it's version 5.
No, this is number 3. And then
Number
number 4. This coming Friday.
Of
the
Apollo,
same talk.
of Apollo 11. And so, you know, I'd have to say my personal view of the Apollo program was that it was a big con. Yes, they went to the moon, they did a lot of good technical stuff, but it was basically to get the Parliament to supply the money.
Oh, you're killjoy, aren't you?
Well, somebody's got to tell the truth. The raffles tonight are a cooker, hand cooker. The last of the multi-tools. My wife is insisting on a box of chocolate, I don't know why. But anyway, she's got chocolates and a bottle of wine, the one small step for man wine. It's actually called one small step wine. And yeah. Oh no, I hooked them all up and checked if they're okay. And well, it's not a thermos flask. I thought it was a thermos flask when we bought it, but my wife pointed out that it's got a warning on it that says use cold drinks
Bless you,
only.
Colin, with
So
support.
maybe put your wine in there. I'm not sure.
Wish you again, Colin, we support it.
All right, so Trevor's going to.
Yeah.
I'll take the light now.
Yep, all right. Yep. Yeah, just don't trip over the tripod.
Well, these are death trap, yeah.
I think generally, when you give the intro for the safety, you've got to be careful not to trip over a tripod. It'd be really funny if the person that just said that tripped over a tripod and they're not even outside in the dark.
Well, invariably, I've got to come over and turn the bloody lights out. And, it's, see that? And it's a real death trap. I'll sit next to Ian.
Yeah.
Dave, you need a remote control for the light.
What?
There is no control to turn the lights on.
So you need a remote control for the lights.
I think we can. I think the switch is looking back to do that.
Do they?
Yeah.
No one ever told me that. I told you it was the wrong way to go to the back to turn it on.
Simon showed me once and I figured it out.
Right. Okay, might as well start hot stove. Otherwise I'll land it on the moon again.
Sign the book.
Right, so as Peter said, I've given this talk for the last couple of Fridays to the public. Originally just for the normal sort of Friday, and then because we got such a big turnout, like this place was packed. So we ran another one and we got, what, about 40 the following Friday, which was last week, and then this Friday, I don't know how many we're going to get.
Yes, 50 something already booked.
50
so
something already.
Probably have about 80 already, 85.
It's supposed to be a much better night too, because
You might get 100 maybe.
Yeah.
Late surge.
yeah, because it's looking like the sun may actually shine on Friday. Just don't blink or you might miss it. But Murphy's Law says, well, see, we're defeating Murphy's Law because Murphy's Law is tied into the first Friday of the month, and because it's not the first Friday, the clouds don't know what to do, so they might stay away. So anyway, I'll be giving this talk again next Friday as well. So this is my third time in about 2 weeks. So I'll be talking about the Apollo missions, not all of them. You'll notice that some numbers are missing, purely because originally I had this talk and it went over 2 months, and I sort of cut it down so it just went over the one viewing night because it was sort of a little bit too long. I'll also talk a little bit about the history as to why it happened and some of the milestones that were set as a result of the Apollo mission, and particularly some of the achievements, some of the firsts, and there were lots and lots of firsts, not just landing on the moon, but lots of other firsts as well. So of course the whole thing kicked off with JF Kennedy. Come on. I did this at home and it worked.
It worked last week.
Yeah, but it was on a different computer. I did this at home.
That's what they all say.
Sure you don't have to put your finger on it.
That's a speed.
Well, we'll go back, try again. Right. Because I ran through this because I used to have it on my work computer, and I thought I really don't want to lose my work computer because it's got all my work on it. So I put it on my other one. So,
That's better.
oh, there's no audio.
Oh, we know it.
We all know it.
Why is there no audio? Is the audio turned on for the...
That's not.
I think you have to plug it in.
Plugged it
It
in?
comes in through the HDMI.
Is it?
No, it doesn't. It comes in through the audio system.
Try it now.
Yeah.
You had to turn that on, didn't I? That was it?
Alright, let's try this back here. No.
Volume on the right,
Which right?
on your computer. Where you hit play, over on the right, the volume's all the way down.
Trevor, put your speaker on there from the.
Over on the right.
Across there, yeah.
Yeah.
Yeah, push it up.
That's it.
Let's go back.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. because that challenge is one that we're willing to accept.
So that was the speech that started it all off. And if you Google it, you'll find it under the "We Choose to Go to the Moon" speech. Probably under other things as well, but if you Google this, you can see the whole thing. It's not really that exciting, that's why I sort of clipped it down to just a few seconds. So that was the thing that kicked the whole mission off. Now, the first thing, as we're probably aware, unlike most of the people from the public, that if you look at the moon through a telescope, you can have a rock the size of a house and you would not see it. So you don't want the Apollo lander to land somewhere that's strewn with rocks as big as houses, because you need it to be quite level. One of the worries was that if it didn't land perfectly straight, they may not be able to take off again. So they wanted somewhere that was basically relatively smooth and flat. But they couldn't see any sort of rocks on the surface that would cause really major problems. So they had to try and get pictures of what the surface of the moon looked like really close up. So what they did, basically, they had these rockets that had cameras, video cameras in the nose, and they fired them at the moon, relaying the pictures back as rapidly as they could, because of course when they impacted on the moon, there wasn't time to replay it. So they had to relay all of these photos back before it finally impacted, and this is in the, there's no sound on this one though. This is from one of those cameras at the nose of a rocket. So as it gets closer and closer, just the last few frames, they can get a reasonable idea of what the surface of the moon looks like at much greater resolution than you ever could from a telescope on Earth. And then the next stage was to actually land on the surface and take some pictures from the surface. So they landed the surveyors, and you can see the surface detail here. It's relatively flat. There's a few rocks that are not particularly big, so no major worries, though at least they could establish that there weren't boulders the size of a house all over the surface. And then Surveyor 3, for those that say we never went to the moon, of course they'd say, oh, this must have been done in a movie studio, because how could you take a picture? But if they look in the background, you'll see there's one of the Apollo landers. They actually landed, their mission was to land near Surveyor 3. They walked from there down to here, and they took some pieces off and took it back to the Earth. Now originally, I know the story goes that they looked at one of the cameras and it had bacteria on it, and the thought was that those bacteria had survived on the moon for all the time it was there. But I read an article fairly recently, maybe a year or so ago, and they've actually now determined that the bacteria were introduced after they brought it back. Not that it had survived on the moon, because at first they thought, well, this is really great, survives in the vacuum and the radiation on the surface of the moon, but they've re-examined it, and it would appear that the bacteria was actually introduced after they'd returned it. So the story is not as exciting as it originally was. They'd also be able to determine the actual temperatures. So during the daytime, 106 degrees, so hot enough to boil water. And at night time, 180 degrees below zero. So a huge change in temperature, hundreds of degrees from maximum to minimum temperature. Now, Apollo 1 was the first mission. And originally this guy here, Gus Grissom, he was the one that was to be the first man to step on the surface of the moon. He was on Apollo 1 with some of the first tests of the equipment. Now, unfortunately, one of the tests they were doing was in a capsule. When they're placed in the capsule, essentially they're bolted in. So they don't have a door handle, they can't just open it. They're actually bolted into the capsule, so they can't get out on their own. And unfortunately, they believe there was a spark in one of the electrical systems, and at the time they were using a pure oxygen atmosphere. It's interesting, the Russians were not. The Russians had already worked out pure oxygen's not a good idea, but because of the Cold War, they weren't allowed to tell anyone. So America continued with pure oxygen, and that spark incinerated the whole capsule. So these 3 guys were strapped into their seats, bolted inside the capsule, and the whole thing just went up because of the pure oxygen atmosphere. So anyone that's probably did this experiment back in chemistry at school, where you have a burning ember and you put it out and you put it in a little jar full of pure oxygen, and it comes back to life again, because oxygen is just so incredibly dangerous. And that after this accident, they changed to having an atmosphere that's much more like Earth's atmosphere rather than pure oxygen, so this wouldn't happen. But of course the Russians had already worked that out. So those 3 guys would not have been killed if the Cold War hadn't been to that level.
Did the Russians work it out by losing men, or
I don't know, or whether they just decided, oh, let's just make it normal. They did they? So they would have incinerated some of their cosmonauts in the process. Right.
Thank you.
Well, high school chemistry tells us that just about all metals burn in a pure oxygen atmosphere, even steel.
Yeah.
So,
It's just,
it doesn't take Einstein.
Yeah.
Obviously didn't have Einstein.
I know, even to cut steel, you use an oxy-torch with oxygen shielding to make it burn through.
Part of the problem that they had, I'm sure they would have known about the effects of the pure oxygen atmosphere.
Yeah.
But part of the problem they had was that the American rockets were much smaller than the Soviet rockets.
Yeah, you would have to carry nitrogen as well as
That's
oxygen.
right,
Yeah.
and that meant that if they were going to go to a pressurized air atmosphere, they needed to have a bigger rocket, and they didn't.
Yeah.
The Russians had beat the Americans in trying to get a big rocket. And so the Americans were basically keeping their weight down by going pure oxygen.
Yeah, because you didn't have to carry the rest of that atmosphere with you.
That's right.
So the next mission was Apollo 4, and you might wonder what happened to the missing ones. The missing numbers, so 1, 2 and 3 were set aside to commemorate the 3 astronauts that were killed in the Apollo 1 mission. So it goes 1 followed by 4. Now Apollo 4, this was just basically to test that they could re-enter the atmosphere. Like, this isn't a Saturn V, this is a much, much smaller rocket, Saturn 1B I think. And there's no people in here. Its mission was basically to get the capsule at the top up into the atmosphere and then use the rocket to slam it through the atmosphere to get a high velocity entry. So they used the actual last part of the rocket, the command sort of level, to fire this top part of the spaceship into the atmosphere to check that it wouldn't burn up, that they'd got all of their calculations, got the materials and everything right, because there's not much point if you burn up on the way home. So they needed to test this. The whole Apollo mission was a series of steps, each one achieving some milestone, so they knew that this particular part works. Now we have to test the next stage. So this one was to check that they could actually re-enter. Apollo 5 had a lunar lander in it of sorts. It wasn't a fully functional one, but this was basically to test that the G-forces from the liftoff didn't actually destroy the lunar lander in the process. So the rocket had a lunar lander in the top, and they fired it with all the acceleration that you would normally expect. And it was just to check that when they popped this out of the top of the rocket, that it wasn't destroyed just from the mere blast off. So again, this was another thing, the next stage they had to check that it was working. Apollo 6 was to actually test leaving the Earth's orbit, that the rocket would actually escape the Earth and leave the Earth. Until then, everything was just essentially an orbital flight of some sort. Just went around the world a few times and then landed, or just continued its orbit. So this one was to actually escape the Earth's gravitational field and into space. Apollo 7, this was a manned mission, was Earth orbital. So it was basically to get these 3 guys up into space, go around, check everything was working, the equipment was working and everything, do so many orbits of the Earth and then re-enter safely. That's the next stage they needed to test. Another thing that they also did, the lunar lander was in the very top stage of the Saturn V rocket. In this case, though, this is just like a target to test that they could actually dock with it and connect. So they made several attempts at docking, release, dock, release, to check that all the equipment that they would use to pull the lunar lander out of the top of the rocket was actually working, that they could actually dock with it and be able to extract it. So they needed to practice and test that technology as well. It was also the first live telecast from space, or I suppose you could say the first SMS from space in today's terms. About 7 years after Kennedy's speech, they actually had the Saturn V ready for launch. So it only took essentially 7 years from when he said go that they had the actual working rocket. To give you an idea how big it is, anyone that's been into the city and they've seen the spire, the Saturn V is virtually exactly the same height as the spire on the Arts Centre in the city. So the next time if you're in the city and you see that spire lit up, imagine a rocket exactly that height, but it goes into space. Now this is a 1 in 200 model that I've got of the Saturn V. So the actual thing is twice that big. So that's about 110 metres to the top there. And the first stage is up to about there, second stage to there, and the third stage. The only bit that comes back is a little bit at the top, which is about as wide as my finger. All the rest of that is just to get that little bit up into space and on its way. Weighs about 3,000 tonnes and can carry 119 tonnes. Now at full thrust, it generates as much thrust as 30 jumbo jets. So you imagine 30 jumbo jets sitting there on the tarmac, all chained together with a Saturn V on the other end, and they rev the engines up ready to take off. The Saturn V will drag them backwards, all 30 of them. That's how much power it outputs. The first stage, which is this section up to here, only lasts about 150 seconds, but takes it to 8,000 kilometres per hour. That's about 8 times the speed of sound, roughly. Now, if you get a chance, I've seen the one at Kennedy Space Centre. I believe they've now moved inside into buildings, but when I was there, it was basically just out in the open in the weather. And when I saw this, I couldn't get over how massive this thing was. You could drive a bus down just one of these. So imagine 5 buses stacked like that. And that whole thing took off and went into space. It's absolutely massive. They have each of the stages is separated and lays on the side so you can walk around and you can see all the pipe work and all the bits and pieces and the little tanks and all that sort of stuff. Really fascinating thing to see. As I say, I know Johnson is now inside, and I think the Kennedy Space Centre they've also brought inside. So if you're at either of those 2 locations, really you need to see this. It's just so massive, particularly when you consider it went into space. It didn't just lie there. Imagine 5 buses just being thrown up into space. Apollo 8. This one was just basically to check that they could actually get to the moon and come back again. So they took off, they went around the moon, and then they came back again. They didn't actually land, they had a lander with them, but they didn't actually land there. It was just to test the technology that they could get there. This mission also set a number of firsts. This was the first time they'd ever launched a Saturn V that had people in the top of it. So this is like a massive bomb. Right? If one of these goes off, then your little escape thing at the top's probably not going to save you. They were also the first people ever to leave the Earth. Until this mission, people had only ever orbited the Earth. They'd never actually left it. And because they left it, well, they went through the Van Allen belts, they had to go through the radiation belts, which a lot of the naysayers say, oh, if they went through there, you know, they'd have been killed by the radiation. But they went through a very thin part of the radiation belt, and they're going at many, many thousands of kilometres per hour. So the total exposure is the equivalent of about one chest X-ray, because they were there for such a very, very short period of time. They were also the first people ever to see the Earth as a whole. When you're orbiting the Earth, you can only see what's below you. You can't see the whole thing. So they were actually far enough away that they could look back at the Earth and see it as a whole. They were also the first people, even though we knew what the other side was like, they were the first people to actually see it with their bare eyes, what the other side of the moon looked like. And they were the first people ever to witness an Earthrise. We see sunrises and we see moonrises, but we don't ever see an Earthrise. They were the first people ever to see Earthrise. They were also the first people to celebrate Christmas out there in space, out near the moon. They were gone Christmas Day, and they came back on the 27th. So this is just a picture taken as they came in. This is the fireball of all the heat from re-entry. Apollo 9, this was to test docking with the lunar lander, an actual lunar lander, rather than, I know the previous one, when they went around the moon, they didn't have a lander with them, sorry. They just went around on their own. This was the first one that took a lander out of the top of the third stage, pulled it out and docked with it, with the actual thing itself, rather than just a target that was on the third stage. So you can see a picture here. This is the third stage of the rocket, and the lunar lander is sitting in the top of the third stage, and here's the little target on the top, which they used to align the command module so that they could dock with this door at the top and connect to it. You can see here, this is the top half of the lander. When they finished with their testing, they just jettisoned it, and I think it landed in the Pacific or something eventually and burnt up. Then July 16th was the launch.
2, 1, 0, all engine running. Liftoff, we have a liftoff, 32 minutes past the hour. Liftoff on Apollo 11. Tower cleared.
We got a roll program. Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on a proper heading.
So that was the beginning of the Apollo 11 mission itself. Now the moon's about 300,000 kilometres away, roughly. If you were to get in your car at 100 kilometres an hour and not stop, it would take you 4 months to get there. That's without any stops for lunch, toilet breaks or anything. 4 months non-stop at 100 kilometres per hour. I suggest if you did do that, you don't bring your kids with you, because there would have to be at least 1 million I have to go to the toilets or are we there yet, right? So at an average speed of about 10,000 kilometres per hour, roughly, it took about 3 days or so to get there. And then when they entered the orbit around the moon, they orbited a few times while they sort of got organised and were ready to actually descend to the surface. This is 4 days later. So this is taken from the command module initially. These things hanging down are actually the contact lights. When it hits the surface, they're basically just like strings, if you like, and when they touch the surface, a little switch will go off to say the contact will be that close to the surface,
and there,
to turn
while
the
out of direct
engines on.
communication with the Earth,
Very high
it
technology.
fired its engine to slow its descent to a touchdown on the near side of the moon.
35 degrees, 750,
So this is
coming
from
down
the
to
land.
23. 540 feet and a 15. 350 feet down at 4. Altitude, velocity light. 3.5 down, 220 feet. Up and forward, come down nicely, 200 feet. 4.5 down, 5.5 down. 100 feet, 3.5 down, 9 forward. 875 feet, that's looking good, down a half. 6 forward. 60 seconds. Lights
60
on.
seconds, how much fuel
Forward.
we've got left?
Forward. 40 feet down, 2.5. Picking up some dust. Big shadow.
You can
4
see
forward,
the
drifting to the right a little.
contact light.
30 seconds. Forward. Contact light. Okay, engine stop. Tranquility Base here. The Eagle has landed. And they'll step off the limb.
They had a camera on the side of the landing.
That's one.
The naysayers say, well, where was the cameraman? Never heard of a tripod or anything like that. Right, so of course a lot of the naysayers say, well, how did they get that? And of course they never thought they had a camera outside. They thought of these things, the naysayers never thought of it. And he had 24 seconds of fuel left. As they came in, they noticed that the area that they were going to be landed automatically was very rocky and potentially dangerous, that they could have landed at an angle and been unable to take off. So they actually took over control and they manually flew the lander a little bit further on past the field of boulders that they'd seen, which is why they were calling out the number of seconds of fuel left, so that he wouldn't find that he's still not in a good spot to land and he's got no fuel left and just crash.
Roger.
Right, so this is where the Apollo 11 landing site is, as seen from the moon, or as seen of the Earth, from the Earth, of the moon. And they stayed there for only 21.5 hours, so not even a whole day. Now this is a picture of Buzz Aldrin, because of course the naysayers say, well, who took this photo? There were 2 of them. One of them was already down and he had a camera. They wouldn't think of that, because of course this must have been done in the movie studio. Yes, of course. And they landed on the 20th of July at about 4:15 American. This is East Coast America, so Florida, New York, all on that side. So sort of later in the afternoon, if you like. Then on the 21st, which was the 22nd in Australia, they actually set foot, which if you were on the East Coast of America, was 11 o'clock at night. So for one thing, America was around the other way. So they couldn't actually see or get the transmission because they couldn't see the moon, and a lot of them would have had to stay up till late. Whereas Australia landed at basically lunchtime. And I was allowed to go home because my family had a TV, and we watched it on our big, I think probably a big 20-inch pie or something, so massive TV for the time. And I went home and had lunch at home to watch it. And Australia, of course, was in probably the best time zone to see it because it was in the middle of the day. Whereas America, who essentially paid for it, they were in bed, or they'd have to get up and have a late night if they wanted to see it. Bad luck. Well, a bad choice there. The original idea was that they were going to come out a number of hours later. The first thing they would do was travel all this way to the moon and essentially put your pyjamas on and go to bed for a few hours and have a sleep. But of course, that's the last thing you'd want to do if you've gone all this way. It's like, I want to go out, I want to go out. And it took them about 3 hours to dress up and put their suits on. And then finally, when they were dressed and they went out, which was hours earlier than they were scheduled, which was also why Australia had to pick up the picture, because America was around the other side, and why Australia sort of had a bigger part to play in it than it would have, because they were keen to get out rather than waiting until they were supposed to. This is a picture of Buzz Aldrin, and you can see there's Neil Armstrong. It's reflected in the visor. And I've looked, and I don't see studio lights, and I don't see a director, and I don't see a cameraman. I don't see anything like that. It looks exactly what I would have expected.
They were careful.
They must have been very careful. I mean, the amount of people have actually said it would be far easier to actually go to the moon than to fake it with that much detail. It would be cheaper. Just go to the moon. It is so hard to fake it with all of the detail they had to do, and you have to have something like 300,000 people sworn to secrecy. So it's so much easier. Just go to the moon. Don't do it in Hollywood.
We'd also just swear the Russians to secrecy too. Can you imagine them cooperating?
I know, that's the thing. And what most of the naysayers don't know is that Russia brought back samples from the moon as well, a little bit later. And when you compare the chemistry of what the Russians brought back, their samples are exactly the same as the ones that Americans brought back. So unless the Russians were in on it at the height of the Cold War, well, they actually went. I know which one I think is probably more likely. So there was a couple of things they had to do. The first thing they had to do was essentially bend down, pick up a rock, and put them in one of the pockets in their pants. Because if something happened and they had to go back immediately, they would at least have a handful of rocks in the pockets in their pants. So that was the first thing they had to pick up, first thing they had to do. They also had to deploy this instrument, which measures moonquakes, because the Earth has earthquakes. The moon doesn't have earthquakes, it has moonquakes. Mars has Mars quakes, and Venus has Venus quakes, right? So we don't have earthquakes on the moon. Now people have asked what causes quakes on the moon, because basically it's geologically pretty much dead. Unlike the Earth, it's got a molten core, and that keeps the continents moving with continental drift and everything. On the moon it doesn't, but it still gets quakes for a number of reasons. One is the thermal expansion. You saw the difference between the daylight and the nighttime temperature, 300 degrees. So basically for 2 weeks it's 100 degrees, and for 2 weeks it's a couple of hundred below. And when you heat something for a week at that temperature and then cool it for that long, it expands and contracts, and that can create shifts in the core and in the body of the moon, and that can create quakes. Another effect that can cause quakes on the moon is just the tidal forces from the gravitation from the Earth. Because the Earth is relatively close, the moon affects our tides with our water, but we also affect the moon with its own body structure, with the rocks that make it up. And so we also help to create quakes on the moon. And of course, meteorite impacts. If a big rock lands on the moon, it'll shudder. Now, unlike the Earth, where an earthquake could last maybe for a minute or two, on the moon, a quake could last for more than an hour, because there's very little moisture in the rocks. On the Earth, when we have an earthquake, the rocks have a lot of water in them, and that helps to dampen the movement. On the moon, because it's dry, it can continue to ring for, like a bell, for more than an hour after a quake. So they last a very long time. And another thing they had to put down is a retroreflector, which was used to measure the distance to the moon. Now these are special reflectors so that if you hit it with a light, that light will be reflected back exactly where it came from. So you don't have to know exactly where it is. Essentially you shine a laser across the surface, which by the time it gets to the moon will be several hundred metres in diameter. So you just have to know pretty close to where it is, and this will reflect that laser light back. So you shine the light, and a few seconds later you see the reflection. Very, very dim, but they can still pick it up. So they would fire a laser from a telescope, from an observatory, and then look for the reflection in the telescope when it comes back. And because they can time the transit time very accurately, and they know the speed of light accurately, they could measure the distance to the moon to within, several inches. They can do it better now by other means, but back in the 60s and 70s, this was the best method they had for measuring the distance to the moon. And this is the thing that I only found out about 3 weeks ago when I was doing this, and that was that both of them were Molly Dukers. They were both left-handers. And I'm a left-hander, which is why I put it up there. And for anyone else in the room who's a left-hander, you're also with a lot of very famous people Albert Einstein was a left-hander. Bill Gates, Steve Jobs, Zuckerberg, Henry Ford. You go down this list and you get more and more important, like Lady Gaga, Angelina Jolie, and even Oprah Winfrey are all left-handers. So if you're a left-hander, you're up there with the first 2 people on the moon and Oprah Winfrey and others, right? It's interesting. I've talked to a few Americans about being left-handed, and they just call you a lefty, is their term. And I'd say, yeah, I'm a Molly Dooker, and they go, Molly Dooker? What's a Molly Dooker? How do you say that word? What's a Molly Dooker? Where does that come from? And I say, it means you're a left-hander. They've never heard of it. And they even find it hard to pronounce, Molly Dooker. So I've educated a few in that. I'm sure they've probably forgotten the word by the time they got back home anyway. So a few days later, they came back to the Earth. This is a picture through their little window. So they're sitting in the capsule, falling backwards at thousands of kilometres per hour. And just a few inches behind their head, it's maybe nearly as hot as the surface of the sun. So you have to hope that they bolted that thing on really well as you're falling backwards. So you see the flames coming past. And then the parachute opens. Of course, they did that in Hollywood too, I suppose. They've got really big swimming pools there, I guess. So the Apollo 11 statistics, you see they only spent, as I say, just under a day there. They brought back 20 kilos or so of moon rocks. And in total they covered over 1 million kilometres because of the number of orbits around the moon. This is a picture of the command module. Well, this is just the tiny little bit that comes back, and that alone weighs 5.8 tonnes. Anyone that has an idea of how quick laptops are these days, this is 2 megahertz. A laptop these days would probably run at 1,000 times that speed.
Are the men still in there, or are they out?
No.
At this point here, I think they probably would have come out. Oh, actually, no, they might still be in because they'd be bolted in here. Yeah. They're out today.
They come out into it.
Right.
After the fire, they made sure that door opened outwards.
Oh, okay, right. Yeah, so they're not in there. Yeah, sorry. But they've picked this up with a crane and they're putting it onto the, probably onto the carrier. And you can see the amount of memory that the computer had, 32K. Most laptops today would probably have at least 32 gigs, which is 1 million times more. And I don't know of any laptop that weighs 32 kilograms. Now this little block here of mine, if you look at it later, you see it's got a picture of the command module on the front, and there's a little window with what looks like something from an Easter egg in there. That's actually a piece of Apollo 11. That's a piece of the Kapton foil that was wrapped around the equipment and stuff. So I bought this many years ago. They're apparently much more expensive and a lot harder to get. Particularly right now, you try and get things like this memorabilia, it's very hard to get. But I bought 11 and 17 with the idea to fill in the gaps, and I never got around to it, and now I probably can't afford to fill the gaps. So that's an actual piece of Apollo 11. Apollo 12 landed on the surface, as I said, and it came to Surveyor 3. And here they're taking off some pieces of it. One thing in particular was the camera. Apollo 12 statistics, you'll see they've gone for a lot longer. They were outside longer and brought back even more rocks, including pieces of Surveyor 3. Apollo 15, you'll notice that I skipped a few. They landed in an area called Hadley Rill. They believe that this is an old if you like, a trail of lava. Yes, Fred?
So what I'm trying to establish, like, with Apollo 13 going wrong,
Yep.
I can understand things going wrong before they landed on the moon, but when you get a rocket built with all the same specifications and all the gear, and it come afterwards, that disaster, couldn't understand
Yeah,
that.
I think it was bad insulation or some electrical problem with it, just a small part of the motor that was a stirrer or something. And it's just one of those things that you can have, like people can buy cars and someone gets a lemon, and yet they might have made 1,000 cars in a week, and one of them they stuffed up everything on it. So on 13, I'm always amazed that they actually had 13. Well, Americans don't have a 13th floor, they don't have 13 anything. In New York, I don't even think they have a 13th Avenue. They go 12th and then 14th, or they have something else in the middle. And yet they had an Apollo 13. I always think if they didn't have Apollo 13, would it have been okay? Is it the mere fact that it was 13? That's why if something's going to go wrong, it would be 13. Why did they choose 13? I don't know. It would have been interesting to know.
Apollo Fred.
Yeah.
In the investigations after Apollo 13, they always talk about the explosion on Apollo 13, but it wasn't an explosion at all. What happened was that the oxygen tank, they had a problem with fitting the oxygen tank, and so they took a spare, but it turned out the spare had been rejected by quality control people, and so they said, "Oh, we'll put it in anyway."
Right.
So they put a rejected tank in, and it was slowly leaking. And what happened was that it took however long for the pressure to actually build up in the spacecraft, and it blew the panel.
Yeah, it's not an explosion as such, like there was no
boom.
No, it was just like you've blown a balloon up and calling it a balloon and an explosion.
And that panel ultimately gave.
Yeah, popped off the side of it. Yeah. So there was no actual combustion related to it.
No, I don't think they would have survived if it
Right.
had been an actual
Yeah.
I'll just put that dodgy tank in because it's not going to get there anyway because it's 13, so it doesn't matter.
Yeah, so if something has to go wrong, why not? Yeah. Yeah, so 15 landed near Hadley Rill, which is an old, where lava used to flow. If you've been to Hawaii or some of those places, they have lava tubes, and that's essentially what a rill on the moon is a lava tube. But it was also the first one to have the Lunar rover. Now these are some of the basic specs. So it weighed over 200 kilos, but could carry 500 kilos. About 3 metres in length and had a range of 92 kilometres, the top speed of 12 kilometres per hour. But the most important thing is it also had seat belts. They were only Velcro, but just enough to hold the people on, because the one thing you don't want to do is fall off. Even though it certainly would have had a dead man switch, so it would have stopped, but you've still got to get yourself up and back into it. So they didn't want the astronauts falling out onto the surface of the moon. Now, 370 years before this mission, Galileo did an experiment on the Leaning Tower of Pisa, where he dropped 2 steel weights of vastly different masses. And the prediction of most of the people at the time was that the heaviest one would hit first, because it's heavier. Of course it would. And the lighter one would follow along behind. But Galileo knew more than what those people did. He knew that if you drop those 2 weights at the same time, they would hit at the same time. Basically, their speed, their acceleration, it doesn't matter how heavy they are, they fall the same. Providing they're not things like, if you dropped a sheet from your bed versus an anchor off a ship, they would land at different times, purely because of the wind resistance that they offer. But he knew that they would land at the same time, and they did. Now, Apollo 15, you've got to remember that there's no air on the moon, so there's no effect like if you had a sheet or something like that. There's no air on the moon, and they took a hammer and a feather, and they dropped those together on the surface. So if we do that experiment here, and I have a hammer, and in here somewhere my feather, I should get a white feather so I can see it. There it is. So if we do this experiment here, we have a feather, and this is a feather from my wife's bowler, right? She doesn't know I've got it, I can give it back. And a hammer. If we drop these on the earth, because we have air, we probably all realise that the feather's going to land after the hammer. And it did. But of course, if you do that experiment on the moon, where there is no air, there's nothing to slow this feather down. So they performed this experiment on the moon, or in Hollywood.
Well, in my left hand I have a feather, in my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Mr. Galileo was correct in his findings.
It does move slightly, but that's because when he let go, he didn't just let it go instantly and put a little bit of a twist on it. Which if you're on the Earth and it wasn't a vacuum, the twist would stop very quickly and the feather would probably go sideways, but you notice that essentially it just went straight down. So the statistics for Apollo 15, you see they returned 77 kilograms. So each time they brought back more and more rocks. And the first one with a rover. Now 17, this was the last mission to the moon. And this was their most ambitious, because they knew they weren't going back. Originally they were slated to do 18, 19 and 20, but the funding was cut. Essentially they won the race and that was it. Yes, Fred?
Trevor, the other Apollos spent more time on the moon than the Apollo 11.
Yeah.
And they got the same packs. How would they account for the extra time?
Well, they just had more oxygen that they would have brought
They did?
with them. Yeah, but they'd have to refill when they went back, I guess, because they didn't stay out there for all that time all in one go. They were out for a short time, go back in, I suppose, have some lunch, morning tea, whatever, have a cup of coffee or something.
Bring back the rocks.
Yeah, bring back the rocks, yeah, otherwise, even though it's only 1/6 gravity, still when you're carrying a couple of 100 kilos of rocks, they do get heavy regardless. Yes. So one of the things they found was orange soil, which was related to the structure of the grain of the soil in this particular area, and it was a geologist actually on Apollo 17. It was the only time they actually took a geologist on a mission, and he noticed this orange soil, and he was like, pardon the pun, over the moon without finding it. They also found some rocks which would have been really great if they could have brought some of these back, but even at 1/6 gravity, you'd need a crane to lift the thing anyway. So that was the last time that they went to the moon on Apollo 17. After 3 days, they took off and they came home.
99, proceeded, 3, 2, 1, ignition. Right away, Houston. Vector good. Ag soft. Good order. I hear you have good product. Okay, 30 seconds. 308 your number. Take out your 1,500 feet, and 8 dot looks good.
Who had the camera to follow it up? So the actual, to actually get to the moon, right, so this part of the lunar lander was in the top of the third stage with the legs folded up, and the command module then connected to the top, docked with it, and flew to the moon with the two connected together. Now I can't see because I've got my glasses on. So I went to the moon like this all the way, and then disengaged. Well, that went down to the surface of the moon. The command module continued orbiting, and then when they landed, the rocket on the bottom of the lower stage was used to allow them to land. But when they took off again, because of course they had practically no fuel left, even in Apollo 11 and even the other ones, but to come back they only used the top part, right? Because people had asked me in previous times when I said this, how did they get back? Because they only had 20 odd seconds of fuel left. They came back in the top half. Now the one thing they had to be sure of for the return journey is that it would start, right? They didn't want any mechanical system or any possibility where they needed an electrical current or something to start the engine, to start the combustion to get them back. So the fuel used to actually take off and go back up to the command module was two chemicals that when you put them together, essentially they just catch on fire. You don't need anything, you don't need electrical current, you don't need an engine, you don't need a pump or anything. You just have to release a valve, open a valve, and when these two chemicals come in contact with one another, they ignite. There's nothing you can do to stop it. So that was how they made sure that they wouldn't go to take off and they got a flat battery or something like that, right? So it's a bit far to bring for the RACV, I guess. So they had to make sure they had the technology for coming back.
Friends of ours said they actually climbed in the capsule in Western Australia. Have they got a replica or something?
Yeah, there's a number of places have replicas of these. If you go to Kennedy Space Centre, they've got replicas of all these things. They've got like a little kids' playground that has a lunar lander.
In Australia, I'm talking about.
Yeah, in Australia, there's nowhere near as many as in America, of course.
No, but
yeah,
there is somewhere that you can go and...
Yeah, because Western Australia probably has that because of Skylab coming in. They had something to do with the space race, I guess, and people would want to go see the stuff from Skylab that came in, which is, I've seen bits of it, and it's just a pile of garbage with a few burn marks on it. But having gone there, you might want to sort of have something else with some interest and stuff. Yeah. But if you go to Kennedy, they've actually got rockets. They've got what they call their rocket farm or rocket garden or something, where they've got all these different, Titan rockets and Centaur rockets and all that, all sort of standing up there. So it's a really interesting place to go if you get there, and the Washington Air and Space as well. Really worth getting to if you're on that side of the world. So Apollo 17, you can see they brought back over 100 kilos this time, and they covered 34 kilometres in the rover. So how many of these people are still alive? You'll see that there's 1, 2, 3, 4 currently still alive, pretty much into their 80s, all of them. Most of them lived to be a pretty ripe old age, a couple of them not quite so. But there's still 4 of them alive and ticking even now. Now, of course, when you look at the moon through a telescope, the first thing you notice is it's covered in craters. Now, if you imagine, if you hit the surface of the moon hard enough with a big enough rock, you can throw some of the rocks from the moon essentially to escape velocity, fast enough that they'll escape the gravitational pull of the moon and out into space. Now, if those rocks happen to come past the Earth at a close enough distance, our gravitational pull could actually pull some of those pieces of shrapnel in through the Earth's atmosphere, and we would see them as a meteorite. Now, you might think that the possibility of a rock hitting the moon, throwing something up into space that happens to get close enough to the Earth that it comes through, doesn't burn up, lands somewhere on the Earth, someone finds it, and they're actually able to determine it's from the moon, you might think it's pretty rare, and it is, but we have actually found a number of meteorites that we know are from the moon. And this little piece here in the little white circle in the bottom corner is my piece of lunar meteorite. So this little sliver of rock is actually from the moon. So it's landed Most of these ones they find in deserts or in the Arctic or Antarctic because they're easy to find. Is somewhere where there are no other rocks. And if you find a rock and there's no rocks anywhere else, and it's nothing like even any of the mountains in the area, chances are it came from space. And when they compare it to the lunar rocks, they see that it's exactly the same chemistry as the rocks they brought back from the moon. But as I said, you might think it's pretty rare, and it is a very rare event. To give you an idea of how rare rocks like that are, we've mined about 90 tonnes of jewellery grade diamonds. So that's 90 tonnes of diamonds for diamond rings. Apollo returned nearly 400 kilograms. We've only found 46 kilos of meteorites from the moon. 1/3 of that total mass is in one single rock. So the total from the moon was probably a rock about that big in total. If you got all of the ones that we've found, we would have a pile about that big. So in comparison to gold, you see that lunar meteorites are worth 50 times their weight in gold. So compared to gold, they make gold look almost worthless because of their rarity. And of course, another question that so many people ask is, can you see the lunar landers through a telescope? And yes, you can. All you need is a telescope that's about the size of the MCG. Unfortunately, we don't have anything even vaguely like that.
They're building them, aren't they?
Probably, yeah, they are doing some of the TMT and all these things. Yes.
39 metres.
Yes, which is probably about, sort of in here. They don't have to scale up a factor of about 5, and they might be there. But of course, the alternative is, if you don't have a big telescope here, you need a much smaller telescope if you go there. So NASA launched their Lunar Reconnaissance orbiter in 2009, and it flew very, very close to the moon, with sufficient resolution that if I put that table on the surface of the moon, it would see it. It would only be a pixel or two, but it would see that you've left something there. So of course, one of the things that it did, wasn't the primary reason that they went there, but one of the things that they did do is they flew over the landing sites. And you can see this is the rocky area, West Crater, that they were coming in over in Apollo 11, and they were destined to land somewhere around here. And so they manually took over and they landed, well, by the look of this, probably about 500 metres away from west. You can see the lander here, and you can see the few little scuff marks on the surface. If you zoom in a bit closer, you can actually see clearly 3 of the landing pads, and the other ones sort of a little bit more obscure. The footprints, some of the equipment that they left behind. You go to Apollo 12's image, you can see there's the lander, some of their bits and pieces in a close-up stage here. Right, again, you can see the landing pads, some of the equipment that they put out there. We go to 17. If you look at the close-up view, you can actually see the very top of the lander, which was where the engine for the top stage was sitting inside. You can see lots of scuff marks. You can sort of make out the flag that's there. There's probably not much left of it now because of the radiation from the sun. They were only very cheap flags. So, and they'd be bleached. Yeah, and they're probably blown along in the wind, I guess, too. Yeah, happens in Hollywood. Yeah. So you can see all of the footprints and everything. This is where they parked their car, if you like. That's their little parking spot. The flags over there and all these other bits and pieces as well. So hopefully the next time you're down here looking at the moon or whatever, down here for a public viewing night, stuck out there in the cold, which I remember doing when it was particularly in the winter. It wasn't very exciting, but now I do it in the warm. So yeah, next time you see the moon up, hopefully you'll appreciate the technology that went into getting there. So if you want to come up and have a look at my little models or drop the hammer on your toe, Peter Lowe could do that. You haven't done anything like that since you dropped your meteorite on your toe.
The meteorite was much more dramatic, yeah, that's right.
Yeah, that's why this is a rubber mallet, just in case.
I never thought of a rubber mallet at that time.
No, well we should have got maybe a rubber meteorite.
Yeah.
Right, do you want me to turn? I'll turn the lights on.
Thanks,
Huh?
Trev.
Great, thank you.
Yes. Go.
There were all sorts of things that I must admit I found fascinating at that time. The Frankston Society ran a whole series of exhibitions, and every time you only had to mention the moon, and you'd get a heap of people to turn up. And the ASB didn't seem to be all that active at that time, which rather surprised me. I don't know. Can you remember what the ASB were doing?
No, didn't do much. No.
We were getting phone calls to go on television. I went on to the Don Lane show and had another character that was with me.
They probably didn't have Perry at the time.
No, there was
He
no,
would have jumped at it.
there was no Perry, that's right.
Yeah, that's right. It's so BP before Perry.
Before Perry, that's right. So we jumped in and we totally scuttled the ASB. I don't think they were all that keen. Another member that was around at that time was a chap called Robert Potter, and what did he go on? Simon Townsend Wonderworld.
Oh yeah, I remember that.
Yeah, and so we were getting the publicity, and I don't know if that actually improved our public profile, but people were very interested. One thing that was rather interesting there was the can you see the landers?
Yeah, with the telescope.
That strikes a personal note for me because that's how I met my wife. In the British space. No, there was an observatory at the Teachers College, and we had B.J. Smith telescope, 12.5 inch telescope there, and Peter Norman. No, is Peter Norman here? Yeah, there he is. Peter Norman and I were giving talks, like astronomy classes, and after the talks, we'd all go out to the telescope, and on a particular day we went out there, and I can, for those of you that can remember the B.J. Smith, it was a big Newtonian, and it was about an F10. It was a big, tall thing. In those days, they didn't have these short folded instruments that they've got today. If you go down to the observatory and look at Bruce Stradaskis's one, that's what they were like, big, long F10 things, and you had to take your life into your hands to climb the ladders to get up to the top of it. And I was setting the thing up onto the moon so that people could go up and have a look. And in the dark, I heard this voice saying, "Can you see the lander?" I thought, oh God. So I walked down, and there was this one of those days young girl, and I was at that age where young girls were more interesting than the moon, and so I decided to abandon all observing. I left it all to Peter Norman to carry on, and I spent the rest of the evening chatting up this nurse, and ultimately married her. So it's amazing how these things can
Did you answer the question?
Oh yeah, no, she probably could answer the question better than I can these days. So she's over the years she's picked up a lot of astronomy, and she's forever. Whenever Perry used to turn up, she would always point out the mistakes he was, because Perry made so many mistakes. You know, you'd listen to him on the radio, and he'd say, you go out and you look in the east, and you say, hang on, there's that bloody thing's in the west.
Maybe he's dyslexic.
Anyway, that was Perry. But it was a very exciting time. The publicity that was going on. Do you want me to pick up whatever you lost? No, it's all right. Oh. My
It was
pickup,
probably my numbers.
yeah, my pickup ability is not very good these days. Yeah, it was it was a very exciting time. There's a lot of things going on, and the society got its start. And if I ever get round to finishing that book,
You got a week.
I'll explain why we kept going and why we've survived when lots of other societies started at that time but never made the grade. And it's an interesting discussion on why one society would carry on for 50 years and others would fail within 1 or 2 years. I remember the Turak Astronomical Society, it sort of faltered for a couple of years and then eventually died. We've had a few that have been offshoot societies from us that have gone by the wayside. And that seems to be the norm for...
We've got the Melbourne Astronomical Society.
Oh, the Melbourne, I'm not sure
What's
that the
his
Melbourne
name?
Astronomical Society was ever a society. It was a sort of
It's a shop front.
It was a shop front, yeah.
Yeah.
We should get David to give a talk on it. The history of the Melbourne Society. He'd probably get sued.
Yeah.
The guest speaker always...
Oh, well, actually, I've got two numbers I prepared earlier.
You read these?
21 through. This is. Oh, yes, it's almost. Blue C56.
56.
56, 5-6.
Read a few minutes, my ticket.
Oh, your 2 books.
You're up on
Who's got 56?
Read your own.
Read your own. We've got a 10-second rule.
Oh, I haven't dropped it on the floor, though.
What about yourself, Peter? You got one?
Yeah, I've got the first 6
What's number?
tickets.
You got 50.
I've got 1 to 6.
He's got 56. C23.
Read your own.
2-3.
Someone along here.
Yes. Peter. 23, right.
Yep.
Well, what would you like, Peter? Do you want the wine? Or do you want, what do we got, on the chocolates? Or
Who's got
or the
one?
gas stove? What would you like?
It's up to you.
Oh, okay.
You can make the executive decision.
Are you a wine drinker? Red wine?
Do you drink wine? No.
No,
That's
definitely
probably a
not.
bad
Do you eat
choice.
chocolate?
Chocolate?
Take them home to the door room.
Yes.
Yeah.
I know Doreen would appreciate the chocolate.
There are. Yeah. You do. Right, next one.
One of the interesting things I find about the story of landing on the moon is that they've got this, we needed to crash the bridge.
Yes, this is not a redraw. This is C9.
No way.
That's me.
That's a 6.
You earned
That looks exactly the same as that one.
No, it's the other way around.
Yeah, no.
That's a 6.
Oh, yeah. Yeah, it still looks exactly the same when I turn it around.
Okay.
I've got to choose what.
You've got to choose.
Cancer will say take the wine.
Would she,
Oh, bugger,
Yes.
Catherine.
is she a red wine girl?
Oh, she's an any wine girl. She even drinks non-alcoholic wine when she's doing dry July.
Is that possible?
Yeah, I know, she didn't last. She's doing dry July, but she has to finish sometime in August. Because she faltered a couple of days.
Oh, okay.
Yes. Oh, no, it's not. C6.
Oh, that'll be
That's
it.
you.
I would have taken the wine or the chocolate from the video.
Oh, so you're the two best gone, are they? Right. God, this is going to take all night.
I'm surprised the end of it. You bought 27 tickets.
C1.
Yeah, that's mine.
It is rigged.
Why
Why didn't you pick a number from a bit higher up, you know?
Yes, pull out in.
You said you got... Maybe shuffling, but like this.
You said you got the first 6 tickets for your seat.
Yeah.
Yeah. Number 4.
Right, you're in, aren't you?
That's right, that's right, you've got 64
Oh,
there.
this is a big one. 72.
72.
Oh, yeah. Anders,
I got the gas stove last month.
he made it into a rocket.
You need to nice toolkit.
You take it into work. You use it in your job. Fix the computers. The little kids.
Computers.
Yeah, that's perfect.
Fix your children.
Looks like a hard drive out.
It'll take forever to pick 2.
All right, I'll pick 2. All right, you read one.
So, this is number 26.
Oh, me.
You're in.
Yeah.
And 14.
14.
This is the lunch.
Which would you like?
They're the seats you have to sit in.
There'll be only one left.
You get the
There's
other
no
one.
gas in it, you gotta get the other one.
Thank you.
Yeah, one of the things that was rather interesting about that period was that, of course, there was a lot of competition, or at least the Americans thought it was big competition about going to the moon. And they really didn't want the Soviets to get in the way. And there were all sorts of things that happened. For instance, they sent, I don't know how many Ranger spacecraft. They only managed to hit the moon once with the Ranger 5.
Well, which is probably the one I got the video of.
Which is one you got the video. All the others missed the moon totally. And
well, they missed Venus the first time they went there too.
yeah, that's right.
Yeah.
And they actually they got some good photographs of the surface, and the argument was that they wanted to test the mechanical properties of the surface. But the Soviets had already landed rovers at that stage and were driving around on the surface of the moon. And so there was this big argument that the astronauts would sink into the dust. You know, and yet the evidence was already there to say, no, it's not going to sink into the dust because the Russian rovers are driving around. But the Americans said, oh yeah, but that's Russian information, you can't trust them. So we'll send our own spacecraft. And that carried on right through the development of space technology. For instance, when they started putting the space station together, they needed to have, obviously, a space toilet. Now, the Russians had space stations up long before the International Space Station. The Mir space stations all had toilets. And the Russians developed that technology. He'd said, it's yours, we'll give you the toilets. No, you can't do that. We can't have our American astronauts going on a Russian toilet. And it was exactly the same with the recycling things. The Russians had developed recycling technology to get drinking water and all. Americans said, no way, any American astronaut's going to drink Russian urine. and so they refused to allow it. So there were all that sort of crap, really. But that was the sort of politics of the day.
And it was like the pen.
The pen was the classic.
The Americans spent a fortune making a pen that would ride in space, and the Russians used a pencil.
Yeah, that's actually a myth, Trev.
Is it?
Yeah, you actually looked it up. It actually was a private company invented that pen.
Oh,
Made money
right.
off it.
Yeah.
When you actually read it, NASA didn't.
But it was
pay
still
that
a lot
money.
more expensive than a pencil.
It was.
Yes.
But NASA didn't spend all that money on it.
Right, but someone did, yeah.
The website you go to is a fact checker.
Right, so you can actually buy one of those pens knowing that if you happen to find yourself in space...
A company built that pen, they give it to NASA to take up to space, so then they can use it as a marketing tool.
Right.
Sounds like
That's right.
You know, when we went to that NASA exhibition, they saw and the Russians said
Yes, I mean, the Russian stuff was being done on the street
Yeah.
because they didn't.
I thought somebody said it was going to be in this council.
And the drive for the government, Soviet government, was not government. They weren't interested in government. They were more interested in developing the weaponry technology. And at that time, and I could give you a whole talk on the space race, but at that time, the thinking was that you put rockets in orbit pointing down and you could fire down from the space station. So space stations were seen as military, but they very quickly realized, once they started working on that, they very quickly realized that the launch time and delivery time was too long. And that, a submarine cozying up to the coast could deliver weaponry far faster than waiting for the moment the war came down, you say, oh shit, the space station's on the other side of the planet, we've got to wait for 3/4 of an hour for it to come overhead. So that was never really going to take off.
But the other big course was the aerial photography.
Oh yeah, that sort of thing was they developed. I mean, the 14-meter telescopes that we use for research today, 14-meter telescopes were in orbit at that time. You don't hear about them, but good old Duncan Steele, who was a researcher that was involved in studying meteorite technology. Eventually, what was the thing that Duncan? Oh, I'm sorry, Duncan Steele was looking for asteroids that were going to crash into the Earth, and he gave a talk at one of the NASA's on 14-meter telescopes that are in orbit, but they're not pointing that way. They're pointing that way, and they can read the newspaper. No worries. So the military technology was just amazing, but you don't hear about that really. And the space program was basically a military program. And the problem that the Americans had, that Kennedy had, was they had a population that had just come out of the war, right? That the Korean War was, I think it was still going at that stage, but they were, was it over, was it?
Yeah, the Korean War was
50 something, that's right. So they just come out of the war. The actual public did not want to go into another war. And if you wanted to go into competition with the Russians, you needed the Senate to approve a lot of money. And there's no way that the Senate was going to approve a whole lot of money for developing more weapons. And so they had to figure out a way of spending the money, because you could spend some of it on the side and not tell anybody, but you couldn't spend that much before the budget started to go funny. So I can imagine in the Oval Office there was a discussion going on, how can we spend all this money on weapons without anyone clicking to it with a legitimate excuse? And some bright spark said, I guess Von Braun said, why don't we go to the moon? Right? It'll cost billions. It'll only cost you this much to get there, and you can spend this much on ICBMs and all that sort of thing. So that's what they did. They started NASA, and it's no surprise that NASA started at that time. The very first project that NASA put money into was developing an ICBM built by Werner von Braun. And he tested the first live test nuclear missile in White Sands.
Oh, David.
So,
the Russians were already doing it.
Oh, the Russians had already done it.
Yeah.
What I thought was rather interesting was that they needed to fire an atomic bomb 5,000 miles to prove that it actually worked. So that's what they did. They didn't tell anybody over there that it was coming their way. They just fired it, and then a few days later the news reports came back and there was a big explosion a lot of light. I don't know if they landed on anybody, but that's the sort of thing you can do if you're not telling anyone.
There's a story I read, I'm not sure if it's entirely authentic, that one of the unused 75s from the remaining
missions that were cancelled,
Yeah.
was put aside so that they could, if necessary, fire a nuclear weapon into the moon if the Russians had decided to militarise the place in some way or other.
Okay, I can't imagine why you'd want to militarise the moon. It wouldn't. It's not as if you're going to
paranoid
invade it.
in those days.
The Americans found themselves completely wrong-footed. Stalin, because the Russians were pretty well broke at the end of the war, but they still had their industries intact because their industries were back away from the European front. And Stalin, I guess with his advisors, realised that the next war was going to be a Soviet-American war. And China
Yeah,
wasn't
the Suez Canal.
Sorry?
The Suez Canal.
No, they just realised that there was going to be a...
That was the height of the Cold War, Peter. Of course it was. They called it was all conscripts. They called 150,000 troops to Egypt, and they all sat down and it all blew over at about 1960. They thought there was going to be another war.
I'm not sure about that, but anyway...
Oh, I do.
The thinking was that there was going to be another war. And Stalin said the weapon of the future is going to, because he had V2 rockets from the Russians, from the Germans, and basically he said the next weapon is going to be a V2 rocket with an atomic bomb on it. He didn't have an atomic bomb, but he did have a lot of V2 rockets. Because they had all the bits and pieces, and the Americans had whiffled away all the engineers, but he still had the rockets, and he grabbed his guy, who was an expert in rocket gliders, and made him in charge of building a rocket, and said, I want to see a V2. And then from there he built the R3, which was essentially an upgraded V2, and then from there he said, now we need to put an atomic bomb on it. And the thinking at the time was that he needed, the atomic bomb was going to be about 5 tons in weight. They didn't know, but they were guessing. The Americans, of course, were telling them everything. And oh, you'd be amazed what the Russians bought from American spies. I mean, they got the plans for the atomic bomb by buying them on the open market, you know, put enough money on there, someone will sell you whatever you need, and so they bought the atomic bomb, but to build the rocket that would launch it, they needed to develop the R2. They really went on to the R3, which was an upgraded R2, upgraded V2. And then there was a phone call, essentially, to Korolev, who was the guy given the job of putting the Russian rocket together. And he was told, we need to have a rocket that can launch 5 ton and throw it 5,000 miles. Because they wanted to throw it across the Pacific. And Korolev just scratched his head and said, "I can't be done." And you can't say it can't be done to the upper echelons in the Communist Party. So he said, "Okay, let me think about it." And the only thing he could do was to take, essentially, he just got V2 rocket engines and he strapped them together with a common fuel feed and a big fuel tank. And then, and that was the basis of the R3.
They're still using it today.
Yeah, and then in order to get the rocket powerful enough, we strapped 4 of them together. Literally put big straps around them, and just fired it. And it needed three of those engines to get it off the ground, and 1 to make the distance. And so the rocket that you see launched today, which is that cone-shaped rocket, that's what that is. And it turned out that the engineering was so solid that they're still working with the same design. It's a little more updated these days, but that's what he did. And they bamboozled the Americans, because when they put up Sputnik, it was for the International Geophysical Year, and people were talking about satellites, and it was all pie in the sky. And the Russians came out and said, yeah, we're going to put a satellite up, and everyone said, yeah. And they thought it was a big joke. And then Sputnik went up. And the thing that really got them was the weight. The first rocket that went up, the first American satellite that went up, was on a Redstone, and the Redstone was actually the R3 rocket. Like if you took the V2 and you upgraded, the V2 was very crude. You actually improved the engineering. That's what a Redstone rocket was. And that's what the Russians had done when the first thing they did. The thing about it was it couldn't go into orbit. It wasn't powerful enough to go into orbit. So what von Braun did is he said, look, I'll put a rocket on the top. And you see photographs of them carrying a rocket overhead. That's how small it was. And they put this little satellite about that big on the top. And that was, what was that called? Can't remember. Anyway, they had this little, it'll come to me.
Yeah, I can't remember.
It was one of these American, Explorer, was it Explorer?
The Explorer, yeah.
And it was just this big. And it was just the top stage. And yeah, we put a satellite up. But what the Russians had done is that they had a much bigger rocket, and they'd also developed the R7 rocket, which was this multiple thing. And when Sputnik went up, I think Sputnik was 50-something kilograms.
Yeah.
It was like that.
About basketball or something, and the Americans put up a tennis ball.
Yeah, that's right. But what happened was that the Americans had no chance of putting up. They could put up a 110-gram satellite, but the Russians had put up I think it was 56 kilos, and that just blew the Americans away. They didn't know how they did that. And then the next one after Sputnik 2, was like 360 kilograms, and the Americans went, "Wow, what did they do?" What they didn't know was that the first one was the actual satellite. But the second one, the Russians told them the weight. What they didn't tell them was that was the third stage that had gone onto orbit with it. So they upped the mass that they were getting into orbit by just lying about it, and so that frightened the Americans. There was a lot of political wrangling going on, and they did it superbly. Good fun, that sort of thing. But eventually the Americans caught up. They had the money and resources, and eventually started putting things to orbit. That was what I found a very exciting time. I was back with a lot of pleasure, really.